Hi guys, today we're going to go over how to solve some of the problems that you're going to see on your final exam. So you're going to need to update your map of Moleville, you're going to need your periodic table, and you're going to need a calculator. We're going to take some of the skills we've learned and apply it to other things. So if you remember how to convert moles using your map of Moleville, we're going to do that, but we're also going to do converting between different substances using a balanced chemical equation. So those are those mole to mole conversions. Now we're going to put it all together. Alright, so this is what your map of Moleville looks like so far. What I need you to add to it is here in Mole City Hall, everything in here is in moles, and what you can do there that's special is you can do a mole to mole conversion. Now notice on the roads we also had things with that, the two dots between them, and that's saying it's a ratio. So we can put a ratio of comparing two different types of substances, mole to mole. And the way we do that is using the BCE. You're probably like, what the heck's a BCE? Okay, we'll write it, and then we'll talk about it. So the BCE, and if you want to write yourself a note, that is the balanced chemical equation. So the balanced chemical equation, you're going to use those coefficients to tell you how much of each thing relates to some other substance. So there's another Moleville rule that you need to know. So this goes in your notes. When you're on the road, you can't change your formula. So let's say you're starting with mass of carbon dioxide. So you have like 32 grams of carbon dioxide or something. You have to convert this to moles, and everything here is all carbon dioxide. So no matter if you want oxygen, methane, whatever as your answer, you can't change it here. So this has to have the same formula on either side of this fraction. A mole to mole conversion, however, that's where you can change it. So if you want to change your formula, you have to go to the Mole City Hall and you have to use a mole to mole conversion with a balanced chemical equation, and you're going to pull from the coefficients. So let's do an example. This is a problem that's similar to what you're going to get on a final exam. The difference of the starting is you're not going to be given the formulas. So see how this is Na2S? You're going to need to know how to balance that, how to know how many of each element. So I'm going to just tell you sodium sulfide, and you have to know that that's Na2S. The other thing is it won't be balanced for your coefficients. So you'll have to balance your chemical equation as well. This won't be given to you because you're literally just being given the words, what reacts, the names of things, and then you have to come up with the chemical equation. So we're skipping those steps right now just to get into the meat of the problem, like the actual stoichiometry. So let's say this is your problem. What mass of each reactant, so that's sodium sulfide and hydrochloric acid, is needed to produce 15.4 grams of sodium chloride? All right, so you're given grams, right? So you're given right here, and you want grams in your answer, like you want mass. So how do you get out of here and come back to the same spot? Well, if you notice, you're not talking about the same thing. You're not starting with sodium chloride and ending with sodium chloride in your math. You're starting with sodium chloride, but you're trying to convert that to sodium sulfide and hydrochloric acid. So you have to use a mole to mole conversion to change your substance. You're going to have to go here to Mole City Hall, use a mole to mole conversion, change it up, so get out of sodium chloride and get to sodium sulfide. And then you're going to have to do another one to get out of sodium chloride and go to hydrochloric acid. And then you go back to the grams, but now with your new substance. So since everything is in grams and that has molar mass, I'm just going to go ahead and figure out the molar mass of everything that I need in this equation, so that way I'm done with my periodic table and I can put it away and just focus on the stoichiometry calculations, making sure my units match up, doing that on the calculator, and I don't need to fuss with the mass. So let's first start with the mass of sodium chloride, just because that's the one that's given to me in the problem. So that's 1 sodium, 1 chlorine. So here are the masses that I got from the periodic table. Plug this into your calculator, and guys, make sure you're using a real calculator. I know that you can do this on the cell phone, and most of the time you guys get it right on the cell phone, but you're not going to be allowed to use a cell phone on the final exam. If it is out, it's a 0. So why not get used to using a calculator so that you know how to type it in properly. All right, so that should get you 58.5 grams. So the molar mass of sodium chloride is 58.5 grams. So we're going to kind of like jot that down and put it aside. The next thing is sodium sulfide. So I'm going to need this because this is one of my reactants. So I'm going to need the molar mass because it tells me molar mass. So that's 2 sodiums and 1 sulfur. So that looks like this. 2 sodiums plus 1 sulfur. And remember, these numbers come from the periodic table. The number here comes from the subscript, so how S doesn't have anything, so that's a 1. Na has a 2, so that's why the 2 is with sodium's mass. Plug it into your calculator, you're going to get 78.1 grams. And then hydrochloric acid, 1 hydrogen plus 1 chlorine, 36.5 grams. Notice I didn't do this mass, I didn't do hydrosulfuric acid, and the reason is it has nothing to do with the problem. Like, I didn't ask anything about it, so I'm not going to waste my time figuring it out. Alright, so I rewrote these masses just underneath each thing that it talks about, just so I have a quick way of referencing it, only because I don't want to go back and forth in the slides. I do not recommend you do this. It's just, it takes up less room on the slide. So you've already written all that on your page. Do not rewrite it under the chemical formula. Alright, so now let's do our stoichiometry, our math. This is going to take a lot of room. So start all the way on the left of your piece of paper or else you're going to run out of room. Always start with your known, so that's 15.4 grams of sodium chloride. We're dealing with sodium chloride, and let's go to sodium sulfide first. We're going to do all that math, then we'll talk about hydrochloric acid. Alright, 15.4 grams sodium chloride. Once you've written your known, then you do your X line. So we're in grams of sodium chloride. We need to get to Mole City Hall so we can do a mole to mole conversion. So the first thing we do is we use this road. We have to divide by the molar mass of what we have. So we've already written that down to be 58.5 grams sodium chloride. Remember, you always divide by the first thing you see. And multiply by 1 mole, and that's 1 mole of sodium chloride. Whenever you're on the road, then the formula has to be the same on the top and bottom. So that's why this is all sodium chloride. All right, so if you have a unit and a formula that's the same, you can cancel them. All right, we are not in what we want. We want the mass of a reactant. We are in moles of something that's a product. So once we're in moles, we can do a mole-to-mole conversion. The key thing for a mole-to-mole conversion is first do units and formula and then plug in numbers after. So currently I have moles of sodium chloride on the top, and I don't want sodium chloride in my answer because I want to know about sodium sulfide. So sodium chloride needs to go on the bottom so it'll cancel. Leave a little room for a number because we're not there yet. We need moles of sodium sulfide to go on the top so we can eventually get that to mass later, but first we just need the right substance. Once you have a mole-to-mole conversion, you look at the balanced chemical equation to see what numbers go with what. So sodium chloride here on the bottom, you find it up here. Here's sodium chloride. It has a 2 in front of it, so you put a 2 as your coefficient. Sodium sulfide is over here. There's no number, so you know it's a 1. Now you can cancel out units, and you've got moles of sodium sulfide. If we stopped here, we'd be hanging out in Mole City Hall for sodium sulfide, which isn't what we want. We want mass, so you have to go back over to the mass mansions, but now you're going back as sodium sulfide. So the first thing you do is you do an X line, because you're doing a conversion, divide by 1 mole, and it's 1 mole of sodium sulfide, and you multiply by the molar mass of sodium sulfide, which we already found in the last slide, 78.1 grams of sodium sulfide. Cancel things that can cancel, and there you go. So anything on the top is multiplied, anything on the bottom is divided. So here's the math you're going to get. 15.4, we don't care about ones, divided by 58.5, don't care about ones, divided by 2, and times 78.1, don't care about ones, grams of sodium sulfide is what's left. Now, notice I've been saying for a while that you always want to write NUF, number, unit, formula, in every single conversion. So see how this is 1, there's my number, mole, my unit, NaCl is my formula. A lot of people continuously, even though I remind them to put all 3 parts, number, unit, formula, they don't do that, and those are the people that are going to mess up the calculations. I guarantee it every time. It's the people who don't write enough, get confused about what goes on the top, what goes on the bottom, you don't check yourself, and that's how problems get answered incorrectly. All right, so I'm going to plug this into the calculator, and there you go. 10.3 grams of sodium sulfide. All right, so it asks for the mass of each reactant. We figured out the mass of sodium sulfide. Now we have to figure out the mass of hydrochloric acid. So we're going to set it up the same way to begin with. So it's the same known because it's the same problem. So you're trying to make the same stuff. You already know how much sodium sulfide you need to begin with. Now how much hydrochloric acid do you need? So it starts very similarly. But now instead of getting out of moles of sodium chloride, we want moles of hydrochloric acid this time. We don't want moles of sodium sulfide. Where did these numbers come from? If you guessed the balanced chemical equation, you are right. Whenever you're doing a mole-to-mole conversion, remember, mole-to-mole is right here, BCE, balanced chemical equation. So that's where those numbers come from. Cancel out some units. And we are currently in moles of hydrochloric acid. So we're hanging out right here with hydrochloric acid. We need to keep going because we want the mass of hydrochloric acid. So you have to X-line it. You're leaving Mole City Hall, so the first thing you hit is 1 mole, so that goes on the bottom. Remember, it's now HCl. And the molar mass of HCl goes on the top. We solved that a while ago, 36.5 grams of hydrochloric acid. It goes on the top. Cancel what can cancel. And then you do your math. 15.4 divided by 58.5 divided by 2 times 36.5. All right. So plug that into your calculator, and you get this. All right, we're going to do one more sample problem with both steps, but make sure you are pausing and asking questions if you have any. All right, so for this one, what is the mass of each reactant needed to produce 8.7 grams of phosphoric acid? So again, we're doing grams to grams, so we're going to need to do those molar masses. So I want you to do the molar masses of PCl5, H2O, and H3PO4, and come back in a second and see if it's the same thing that I got. Here's another sample problem that's similar to what you might get on your final exam. Again, remember, you won't be given the formulas, so you'll just be given the names, and you won't be given the balanced chemical equation. You'll have to balance it yourself, but so far I've given this all to you. So this problem says what mass of each reactant, so it's the same. We need the mass of PCl5 and the mass of H2O will be needed to produce 8.7 grams of phosphoric acid. By the way, if I have any acids on there, I'll give you the names of those since we did not go over how to name acids. All right, so the first things first, since you're going from grams to a mole conversion and back to grams, you're going to need the masses for all 3 of these things. So this time I want you to pause the computer, figure out the molar mass for all 3 of these, and then bring the computer back and I'll have the answers for you. But pause the video, figure it out yourself. Okay, so here is the answer and the work to solve for those molar masses. Please make sure that you are correct, and if you are, go ahead, and if not, try and figure out what you did to kind of get snagged. Now that you have all the masses solved, so you don't have to worry about solving for the molar mass during the stoichiometry, let's go ahead and do the work. Well, actually, you're going to do the work, and you're going to freeze the computer and then solve it and come back and make sure it's right. So remember, you have to do each of your reactants, but we're going to start with PCl5, solving for the mass needed of this first. And you're given H3PO4, phosphoric acid. So here's your known, that's where you're starting. So you're going to get out of grams of phosphoric acid, go to moles, do your mole-to-mole conversion, and then come back for grams of PCl5. Okay, freeze the computer, and good luck. So here is the math that you should have done. Notice the proper units cancel, and in the end you're just with grams of PCl5. Notice when you don't have moles on top and bottom, so this is moles and grams, it's the same substance. phosphoric acid. When it's moles to moles, you can have two different things, and the number comes from then the coefficient in your balanced chemical equation. So this is a 1-to-1. Here is the math that you would do to solve this. So you should have gotten 36 grams of PCl5. All right, the next one, now solve for water. So go ahead and freeze the computer, do the math. Remember again, go to moles of H3PO4, then do your mole to mole conversion, and then go back to grams, but now for water. Okay, go ahead and freeze and solve. All right, here is the work that you should have done. Check each one, make sure that your converters are exactly the same. So you want the same stuff on the top, same stuff on the bottom. Make sure as you go from left to right, like everything is in the same order, so you're doing stuff properly. Here is the math that you should have. And the final answer should be 13 grams of water. All right, best of luck practicing for the final exam. Make sure you ask questions ahead of time so you can have plenty of time to master the material. Okay, good luck.